Hey kiddos. All right, so we are going to start reviewing for the Unit 3 test by completing the Unit 3 practice test. Remember, to find the Unit 3 practice test, you're going to go into Illuminate Education, and you are going to look for Scanlon 2223 Unit 3 practice tests. I'm going to go ahead and do all of the problems with you. There will be several recordings showing you how to do all of these. I strongly recommend that you pause the video and you get something to write with and something to write on, and that you organize your notes very clearly so that when you go to take the actual test, you can look back at how you completed the problems on the practice test and use that as a guide for you when you're completing the actual test questions. Okay, so I'm going to go ahead and share my screen. Remember, you are allowed to use Desmos to support you as you are doing the math. But I'm going to go ahead and just use my handheld calculator during this video instruction, so I'm not flipping back and forth between Desmos and what I'm showing you. All right, go ahead and get ready to do question number 1. The number of these questions are the same order as your actual test questions. So if you number your paper appropriately and show the work for yourself in your notes, then it should mirror what you're going to see on the actual test. Okay, let's start with number 1. Question number 1 says, the model of an airplane is 10 inches long. If a real airplane is 130 feet long, which of the following have the same constant of proportionality as the model airplane to the actual plane? Select 2 that apply. All right, usually when you're taking a test, when the questions are pretty difficult, you want to read them twice through and you want to try to identify some important pieces of information. So I'm going to go ahead and do that. It says the model airplane is 10 inches long. If a real airplane is 130 feet long, which of the following have the same constant of proportionality? And they want you to select 2 that apply. Okay, so the first thing that I want to do is I want to create my proportion or my fraction that compares my model of my airplane to my real airplane. So I'm going to start out by writing that as the model compared to the real, the actual. And I'm color coding it to help you guys figure out what goes where. Now, whenever I create any fraction, anytime I'm looking for the model's measurements, it's going to go on top. And anytime I'm looking for the actual measurements of the airplane, they're going to go on the bottom, right? So my model's airplane measurements were 10 inches. I'm going to disregard the label. We're not converting here. This isn't a question that is asking us for conversions. If you look at your answer choices, you could see that they're in inches and in feet, right? Here's your inches, here's your feet. So they're not asking you to convert. They're just asking you to create fractions. Okay, so my model is 10 and my actual or my real airplane is 130. Okay, and what I'm looking for now is a constant of proportionality. It's basically this fraction simplified or a different form of this fraction that is equivalent. Okay, so what I'm going to do is I'm going to go ahead and use all of the different answer choices. Remember, I'm looking for 2 different answers that are correct, and I'm going to use the numbers that they give me in each of the answer choices to try and create what is called a proportion, another fraction that is set equal to this original fraction. Okay, so we're going to go to answer choice A, and I'm going to look for the information that they're giving me here. I'm going to color code. So if I'm looking for the model, I'm going to underline in red. So it says the model of the car is 18 inches. And then the real car is 18.5 feet. So I'm going to go ahead and put the model's measurement up on top of 18. And then on the bottom, I'm going to put the actual, which is 18.5. Now, guys, I don't know about you. I don't even need to do the math. My logic tells me that there's no way that these 2 fractions could be equal to each other. Compare the numerator to the denominator in the first fraction. Well, the numerator is 10 and the denominator is 130. Those are really, really far apart numbers. There is no way that 18 compared to 18.5 could be the same exact thing as 10 over 130. There's no way that these two fractions could be equal. I know that, maybe you didn't know that. So I'm going to actually go back and show you the math to tell you how I would go ahead and approach these problems. I'm going to use what's called cross products. All right, so you might want to write that down in your notes. You want to use cross products. Well, what are cross products? That's when we take our two numbers that are diagonal from each other and we multiply them together. Okay, so I'm going to take 130 and I'm going to multiply it by 18. And if these two fractions are equal, then when I go to do the other multiplication of the cross products of 18.5 times 10, I should get the same exact thing. These two answers should be equal to each other. All right, well, I don't need to use a calculator for the right side. I know that 18.5 times 10 is 185. I'm just moving that decimal point one place to the right. And I'm now going to go ahead and do 130 times 18, and I get 2,340. And you can see very clearly that these two numbers are not equal to each other. We are trying to find two numbers that are equal to each other. So this answer choice of A, I'm going to eliminate. I'm now going to continue this process using the numbers in letter B instead. Okay, but the process stays the same. I'm going to do the same thing every time. So here I go color coding. It says an actual train car is 65 feet. They tried to trick you there. Notice the actual should be underlined in orange. All right, and then the model is underlined in red. Toy train car is 5 inches. So I'm going to put 5 on top and I'm going to put 65 on the bottom. They're going to try and trick you just like this on the actual test. So please pay attention to that. Okay, once you've got it set up properly, you're going to go ahead and do those cross products again. So I'm going to multiply 10 times 65. And then I'm going to multiply 130 times 5. And I'm going to see if I get the same thing. Remember, they should be equal. I know that 10 times 65 is 650. I'm going to do 130 times 5, and I get 650. This shows that the constant of proportionality is the same. It tells you that those two fractions are equivalent. So answer choice B will be one of my 2 correct answers. All right, let's go on to answer choice C. Remember, we're looking for 2 correct answers. Okay, so now for letter C, I am looking for the tree house is 12.5 feet and the model house is 6 inches. So the tree house is the actual, that's underlined, whoops, in orange. They almost caught me on that one. Tree house is underlined in orange because it's in feet. And the model is 6 inches. So I'm going to put 6 inches on top. And on the bottom, I'm going to put the 12.5 feet. Okay, again, now that I've got it set up, I'm going to use cross products. I'm going to multiply 12.5 times 10. Now remember, it doesn't matter the order that you multiply in. I could do 12.5 times 10, or I can do 10 times 12.5. It doesn't matter. And then I'm going to multiply 6 times 130 and see if I get the same answer. I know that 10 times 12.5 is 125. And 6 times 130 is 780. Okay, so very clearly you can tell those are not equal, therefore I'm eliminating answer choice C. Now on the test, if you wanted to, and you were very, very confident in your math, you could just assume that the correct answer then would be D. All right, but I'm gonna go ahead and prove it just to show you. Again, I'm gonna follow my color coding. So a semi-truck is 91 feet long and a model truck is 7 inches. The semi-truck is the actual, so it's underlined in orange. And the model is underlined in red. Okay, so I'm going to put 7 on top, and I'm going to put 91 on the bottom. I'm going to use my cross products. 10 times 91, or 91 times 10, doesn't matter. And that should be equal to the other cross product of 130 times 7. All right, well, 91 times 10 is 910. And 130 times 7 is 910. Okay, so it does check, therefore the correct answer for number 1 is A and D. Make sure you've taken down all the notes you need from this. You might actually even want to copy down the actual problem. You could pause the video and copy down the entire problem, color code everything. Whatever you choose you need to do in order to be successful on the test is a great idea. All right, when you're ready, you're going to go ahead and move on to question number 2. And here we go. Question number 2 says, Francis is making monster cookies for a party and wants to make sure that everyone gets at least one monster cookie. The recipe calls for 1/4 of a teaspoon of salt for every batch of cookies, and each batch makes 12 cookies. If Francis has invited 48 people, how many teaspoons of salt will he use? All right, it's a lot of information. So again, I'm going to read it twice and try to pull out the most important pieces of information. It says Francis is making monster cookies for a party and wants to make sure that everyone gets at least one monster cookie. There's no math in there that I need to pull out. The next sentence says the recipe calls for 1/4 a teaspoon of salt for every batch of cookies. And every batch makes 12 cookies. So the way that I'm reading that is that it takes 1/4 a teaspoon for every 12 cookies. Okay, I'm going to write that down by using a ratio. I'm going to compare two different things. So I'm going to compare my teaspoons. Actually, let me color code this. I'm going to compare my teaspoons to my cookies, just like we did in the last problem. All right, so I'm going to use my setup as teaspoons. I'm going to abbreviate that as TSP. All right, I'm going to compare that to my number of cookies. All right, so there's my setup. I'm going to continue reading this problem. It says, if Francis has invited 48 people, how many teaspoons of salt will he use? So the 48 people are going to get at least one monster cookie each. Therefore, the 48 people are going to get 48 cookies. So instead of people, I could really call this cookies and underline that part in orange. All right. And what I'm trying to figure out is the number of teaspoons. It asks me how many teaspoons. That's my unknown. So I'm going to set up what's called a proportion. We are going to use a proportion here. Well, that's kind of what we used in the last problem. All right, and I'm going to use my setup right here to help me figure out what numbers go where. So for the teaspoons, I'm going to put 1/4 of a teaspoon in the numerator or on top. And on the bottom, I'm going to put my number of cookies, which is 12. So for every 12 cookies, he uses 1/4 a teaspoon. All right, now I'm going to set it equal to another fraction. And in this fraction, it tells me that I have 48 cookies. It's underlined in orange. So my 48 goes on the bottom because that's where my cookies are. And I don't know how many teaspoons that is. So that means my numerator is going to be a variable, maybe X, maybe N, maybe T for teaspoons. All right, and now I need to solve this proportion. You were taught how to solve proportions in several different ways. The easiest way in this problem is to say to yourself, how do I get from 12 to 48? What can I do to 12 to give me 48? And that is to multiply by 4. Okay, if you didn't know that, you could take 48 and you could have divided it by 12 to figure out how you got there. You could have used a calculator for that. You could have used long division. It's up to you. If you're not so good with your 12 facts, you probably want to use a calculator. All right, so I know that to get from 12 to 48, I times it by 4. Whatever I do to the bottom, I'm going to do to the top. So I'm going to take 1/4 and I'm going to multiply it by 4. And that's going to give me what X is. So off to the side, I'm going to do 1/4 times 4. Remember, when you're multiplying a fraction by a whole number, you put your whole number over 1. Every whole number sits invisibly on top of the number 1. And then I'm going to multiply straight across. So 1 times 4 is 4. 4 times 1 is 4. 4 over 4 is the same as 1. What does this mean? Well, it means that X is 1, which also means that X is 1 teaspoon. And that's where my setup comes in. It helps me know what I've found. I found the number of teaspoons. So the correct answer to this problem is 1 teaspoon. That was one way to solve this problem. Okay, now another way to solve this problem for those of you who don't like that method, and again, if you do like that method and you want to copy it down, go ahead and pause the video. For those of you who want another way, you can use cross products just like we did in the other problem. Okay, so you could take 1/4 times 48. And you could say that that's going to be the exact same as whatever 12 times x is. And then you could solve this equation that we've just created. All right, is it easier? No, but it might be the process that you prefer. So I'm going to go ahead and I'm going to do what's on the left side first. I'm going to do 1/4 times 48. I'm going to make myself a little bit of extra room down here. Okay, so I'm going to do 1/4 times 48. I'm going to put my whole number over 1. Then I multiply straight across, and I get 48 over 4. Okay, which I am then going to simplify. I'm going to divide 48 by 4. 4 goes into 4 once. 4 goes into 8 2 times. So 48 over 4 is the same as 12. Okay, so simplifying the left-hand side of this equation, I get 12. 12 equals 12x. To solve the equation, I divide both sides by 12. And I get x equals 1. Either way, you're going to get the same answer. Okay, that's question number 2. I'm going to go ahead and clear it. And we'll move on to question number 3. Question number 3, Stella is baking a pie. The recipe calls for 1.5 pounds of flour for every 1/2 cup of sugar. How many pounds of flour should Stella use for 1 cup of sugar? All right, let's go through and pull out the math pieces. Stella is baking a pie. The recipe calls for 1.5 pounds of flour for every 1/2 cup of sugar. So we are comparing flour to sugar. There's my setup or my fraction. Oops, this part should be written in orange, pardon me. Okay, so now that I've got my setup, I'm going to continue reading. It says, how many pounds of flour, that's my unknown, should Stella use for 1 cup of sugar? All right, so I'm going to create my new fractions that go along with the setup that I've created. In the numerator are going to be my flour measurements. So 1.5 pounds of flour. I can call that 1.5, or I could call that 1.5, guys. Might be much easier for you to use the decimal representations instead of the fractions if you're better with decimals. Most of you know that 1/2 is 0.5. Okay, and 1/2 cup of sugar, again, I could call that 0.5 if I want, if I'd prefer to use the decimals. And then I'm going to go on and it says how many pounds of flour, that's my unknown. So I'm going to call that X because I don't know it. And my amount of sugar is 1 cup. Right, so this should be easy. This is the 3rd time we're doing it. So from here on out, we are either going to use cross products or we're going to try to figure out how to get from one number to the other. How do I get from 1/2 to 1? Well, I double it. I either add itself or I times it by 2. I'm going to choose to write it as times by 2. 1/2 times 2 is 1. Whatever I do to the bottom, I'm going to do to the top. Okay, so what I'm really going to do over here off to the side is I'm going to take 1.5 and I'm going to multiply it by 2. Now, guys, those of you who have good logic, you could probably figure this out in your head. If I have about 1.5 cups and I have another 1.5 cups and I put them together, I have 3 cups altogether. Right, but if you're not so good at that, we have to do the math. So again, we could convert this to decimal and do 1.5 times 2. Or I'm actually going to just do the math and show you how to do it. I'm going to take 1.5 and I'm going to rename it as an improper fraction. I'm going to do 2 times 1, which is 2, plus 1 more, which is 3. So 1.5 is equal to 3 over 2. All right, so now what I'm going to do is I'm going to take 3 over 2 and I'm going to multiply it by 2. Because that's what I'm supposed to be doing originally, timesing it by 2. I'm going to put my whole number 2 over 1, and I'm going to multiply straight across. 3 times 2 is 6. 2 times 1 is 2. And 6 over 2, 6 divided by 2 is 3. What does this mean? That means that you need 3 pounds. You need 3 pounds of flour for every 1 cup of sugar. 3 pounds is the correct answer. Again, we could use some logic skills in here. We need way more flour than sugar. Let's come back up here to the beginning of the problem. Beginning of the problem, you can tell that you are using 1.5 pounds of flour for every 1/2 cup of sugar. You're using way more flour than you are sugar. So if I have a cup of sugar, I have to have way more flour. I have to have way more than 1. So it can't be either of these two. All right, so at least I can have a 50-50 chance of getting the correct answer if I'm clueless, if I forget how to do it. But of course, you should be writing down the process so you know what to do. So go ahead and make sure you've done that and join me on question number 4. Okay, question number 4 says, a superjet can fly from New York to Seattle in 45 minutes. The distance from New York to Seattle is approximately 1,575 miles. How many miles per hour is the superjet flying? Now, we've already done this in a warm-up in class, but we are going to go ahead and do the same process we've been doing before. All right, we are going to underline the most important pieces of information. And so what we're given, it says a superjet can fly from New York to Seattle in 45 minutes. The distance from New York to Seattle is approximately 1,575 miles. Then the question says how many miles per hour? We got a problem here. We've got 3 colors, right? It doesn't say how many miles per minute. It says how many miles per hour. So when we go to set up our proportion or our setup, we're going to have to really think about this. All right, so we've got a couple options. The first thing I'm going to do, though, is I'm going to focus on my miles per minutes. All right, so I'm going to go ahead and write this as miles per fraction bar minutes, because that's what I'm given in that first sentence. All right, and so I'm going to write that fraction using the numbers now. So it went 1,575 miles, and it took it 45 minutes. And I'm trying to figure out how many miles that is in an hour. So the easiest way to do this is to think about how many minutes are in an hour. Well, you all know that. You know that 60 minutes equals 1 hour. All right, so our denominator of our new fraction when we're talking about minutes and hours is going to be 60. We're not going to put a 1 down there. Even though it says miles per hour, we have minutes that we're using. So we want to make sure we're converting in the same units of measure. Okay, so hopefully that wasn't too big of a change for you. Instead of putting a 1 down here, I use 60 because we're talking about minutes. And we are trying to figure out how many miles that is. And that's what I don't know. So that's my variable. All right, so this one definitely had a little twist in it. If you caught that twist, this is no different than the other problems, the other proportions we've been solving. The only hiccup here is trying to figure out how to get from 45 to 60. I can't think in my mind what I can multiply 45 by to give me 60. I could take 60 and I could divide it by 45, and that would tell me what I multiply by. Okay, so I could do 60 divided by 45, and it gives me 1.3 repeating. This is really difficult to multiply by, all right, because it's a repeating number. So instead of doing that, I'm going to actually just use cross products, and I can avoid all of that. All right, so the other strategy, like I've said, is to cross multiply. So I'm going to do 60 times 1,575. And then I'm going to go ahead and do 45 times x. Okay, so 1,575 times 60 equals 94,500. And to solve this, I'm then going to divide both sides by 45 to get X by itself. Okay, so I get X equals whatever I get, 94,500 divided by 45, and I get 2,100. Okay, let's interpret that answer. Let's think about what it means. What it means is that X is 2,100. And again, because my label up here says miles, that means that that Superjet can fly 2,100 miles every 60 minutes, which is the same as every hour. Okay, so I'm looking for 2,100. That is my answer. And no kidding, it's a Superjet. Nothing flies that fast. That's pretty crazy. All right, let's do one more problem. We're going to do question number 5. Oops. All right, this one says, Miss Williams just opened a sports store and is determining what to charge for bundles of football jerseys. Which table of prices represents a proportional relationship? All right, what we need to do here is remember what a proportional relationship is. And remember, a proportional relationship is a relationship that has, there are a couple of ways you can think about this, where every fraction is equal to each other. Every fraction is equivalent. You could think of a proportional relationship as a pattern. So as your X values increase, your Y values increase at the same rate. Okay, and if we were to graph these, which I don't think is a very efficient way to solve this problem, but you could, if we were to graph these, remember in a graph, visually, what you would see in a proportional relationship is that your graph would go through the origin, which is 0, 0, and it would make a line. Right, so if I were to graph all 4 of these different sets of ordered pairs, and an ordered pair would be formed by taking your X value and your Y value and writing them as an ordered pair, 15, 45, right? If I were to graph all of these ordered pairs in this first answer choice, they should go through the origin and they should make a line. Only one of them is going to do that if I were to do this visually. But this is not the most efficient way, so I am not going to choose to graph it. Okay, and I can choose between these other 2 options. Do I want to write all of these as fractions and see if they're equivalent to each other? Or do I want to look for a pattern? All right, so I think I'm going to choose, it doesn't matter, to be honest. I don't know that one's more efficient than the other. I'm going to try one. I'm going to try by doing the fractions are equivalent for choice A, and I'm going to see if that works. If it is not choice A, and if it was hard to do, then I might switch methods. Okay, so I'm going to go ahead and I'm going to take these ordered pairs and I'm going to write them as fractions. So I'm going to put the jersey bundles on the top and the price on the bottom. Okay, so I'm going to put the jerseys on top and then I'm going to put the price on the bottom. It's probably better to start with that setup so you know what you're doing. So 15 jerseys cost $45, and I'm going to just go down and I'm going to list all of these fractions, and then we'll see if they're equivalent. 25 jerseys cost $75. 35 jerseys cost $105. 50 jerseys cost $150, I think that says. And 75 jerseys cost $225. What I'm trying to see is, are these all equal to each other? Right? There are a lot of ways that I can do this. The fastest way to compare fractions is to convert them all to decimals. And in order for me to do that, I'm going to show you that with the first one, for 15 over 45, I would take my numerator, my top number, and I would divide it by my denominator, my bottom number. Okay, if I'm punching this into a calculator or into Desmos, I put the numerator in first, I hit the divided by sign, and then I put the denominator in. Okay, and 15 divided by 45 is 0.333333333 all the way across your screen. We call that a repeating decimal. We call that 0.3 repeating. Okay, so now what I want to do is I want to do the same thing with all of these other fractions, and I want to make sure that I get that same answer. I'm looking to see if every one of them also equals 0.3 repeating. So I'm going to do 25 divided by 75. My calculator shut off. 25 divided by 75 is 0.3 repeating. Okay, I don't know if you can see that, but if you look at my screen, you can see that it's 0.33333 all the way to the end. It means it repeats. I'm then going to do 35 divided by 105. Same thing. I get 0.3 repeating. So far so good. This is looking to be good. 50 divided by 150 is also 0.3 repeating. So as long as this last one follows that pattern, I've found my answer. And then I'll do 75 divided by 225. And check it out, guys. Letter A worked out perfectly for me. These are 0.3 repeating. All of these are the exact same. So this is what we call a proportional relationship. All right, so the correct answer choice for this one is letter A. So that worked out well. However, it didn't show you what a bad answer would look like. So I am going to pick letter B just to show you how an answer would look like if it were not correct, just to make sure you understand. Okay, so I'm going to erase. I'm still going to use the same process. This process was pretty easy, especially seeing that I get to use a calculator. All right, and I'm going to change my fractions. I'm going to choose answer choice B. Again, just to prove it's wrong and to show you what a wrong answer would look like. Okay, so my first fraction would be 15 and then 60, 15 jerseys for $60. And that's supposed to be the same as 25 jerseys for $100 and 35 jerseys for $140 and 50 jerseys for $200 and then 75 jerseys for $225. Right, so the first thing I'm going to do is I'm going to convert to decimal. I'm going to take 15 and I'm going to divide it by 60. So 15 divided by 60 gives me 0.25. All right, so now what that means is that all the rest of these fractions have to give me that exact same decimal, or it is not proportional. So I'm going to try the second one, 25 divided by 100. And 25 divided by 100 is 0.25. So far, so good. 35 divided by 140 gives me 0.25. Then I'm going to do 50 divided by 200. And that gives me 0.25. Please don't make me a liar. And finally, I'm going to do 75 divided by 225. And I get 0.3333333333. All right, so this last fraction is what makes this not proportional. This is not equal to all of the rest of these decimals, therefore it is not proportional. All right, so that's what it will look like if it is incorrect. All right, those are questions numbers 1 through 5. I will record another video for the next set of questions.